Imagine a place in the universe from which nothing returns. No human, no light, no sound. A void that swallows you whole and leaves absolutely no trace of your existence. You simply cease to be. Hidden right at the center of this photograph of our Milky Way is a silent destroyer, a supermassive monster named Sagittarius A star, packing the mass of 4 million suns. For centuries, science laughed at this idea. In 1783, a British scientist named Michell imagined an object so dense that its gravity would trap light itself. He called it a dark star. In a world governed entirely by Newton's laws, Michell's peers treated him like an eccentric novelist. Even the brilliant mind captured in this photograph struggled to accept it. Albert Einstein proved that gravity bends the very fabric of space and time. Yet when his own equations pointed to the possibility of an endless cosmic pit with infinite gravity, Einstein rejected the concept. He called it practically impossible. Our brains are wired to reject objects like this. We rely on the physical laws of cause and effect, time and space. A black hole represents the total collapse of those basic rules. While Einstein doubted his own math, a German physicist found the exact proof in the most unlikely place. Look at this photo of the front lines of World War I. Somewhere in trenches just like these, dodging artillery fire, Karl Schwarzschild solved Einstein's equations of general relativity by hand. This diagram illustrates exactly what Schwarzschild calculated from that war zone. He discovered that if a massive star compresses past a highly specific mathematical boundary, now called the Schwarzschild radius, its gravity becomes so extreme that it forms an inescapable well. Nothing gets out. It took nearly a century for humanity to actually see it. This photo captures the global press conference in 2019, the exact moment scientists unveiled M87 star. By linking radio telescopes across the entire planet, they captured a blurry, glowing orange ring 55 million light-years away. A 100-year-old math equation finally caught on camera. But the visual proof only deepened the nightmare. The physicist pictured here, Stephen Hawking, proved that black holes aren't static prisons. Through a quantum process we now call Hawking radiation, they slowly leak energy. Over trillions of years, they shrink, evaporate, and disappear completely. Fundamental physics dictates that information can never be destroyed. The state of every atom must be accounted for. However, if a star falls into a black hole and that hole eventually evaporates into empty space, its data seems to vanish entirely. This discovery left a massive, glaring contradiction at the very base of our scientific understanding. We found the monster, only to realize we don't know how to survive its math. Here is the profound irony of these cosmic pits. The darkest, most destructive entities we know of actually generate the brightest light in the cosmos. Supermassive black holes fuel quasars, spinning superheated gas and dust at near light speeds, blasting out imaginable levels of X-rays and gamma rays. Extreme gravity brutalizes time. Near an event horizon, space curvature drags on seconds. You experience a minute, while decades pass on Earth. We measure this in orbit. GPS satellites experience tiny time dilation from Earth's mass. Engineers constantly adjust their clocks, or navigation fails. The physical experience of approaching one depends entirely on its size. Fall toward a small, stellar mass black hole, and gravity pulls your feet so much harder than your head that your body instantly stretches into a literal string of atoms, a process physicists call spaghettification. But cross the horizon of a supermassive black hole, you wouldn't feel a thing. You'd slip quietly past the point of no return. A black hole actively manipulates the raw ingredients of our reality. It dismantles physical matter, slows down time, and outshines the galaxies it anchors. When two of these massive bodies crash into each other billions of light-years away, the sheer violence of the impact sends ripples through the fabric of space itself, like stones thrown into a cosmic pond, and we can actually measure those ripples from the facility you see here. At the LIGO Observatory, scientists use highly sensitive lasers hidden inside these massive concrete tubes to detect spatial movements smaller than 1,000th the width of a single proton. When LIGO successfully captured the distortion of two colliding black holes, researchers translated that microscopic wiggle into audio. It produced a short, high-pitched chirp. For the very first time in human history, we literally heard the friction of the universe. Those gravitational waves are passing through the Earth, through your house and your body, right now. This diagram visualizes a proposition taking hold in theoretical physics right now.
Some scientists suggest that 13.8 billion years ago, a massive star in an older universe collapsed, and inside the event horizon of the resulting black hole, our universe was born. Our reality might just be an expanding bubble inside a higher dimensional black hole. Under this framework, black holes scattered across our galaxy function as seeds for new realities, an infinite chain of universes spawning black holes, which in turn incubate new universes. But every universe has an expiration date. Trillions of years from now, long after the last star burns out, even the black holes will fall victim to Hawking radiation. They will slowly evaporate away, leaving behind a cold, completely silent void, a cosmic heat death. Fortunately, that final curtain call requires a universe billions of times older than our own. At 13.8 billion years old, our cosmos has plenty of time left on the clock. The events occurring beyond the absolute boundary of an event horizon remain impenetrable. No equations work there, and no signals can ever escape to tell us the truth. Stephen Hawking spent his life unraveling these monsters from a wheelchair. His advice was simple: remember to look up at the stars. Because the darkest, most terrifying voids in the night sky might actually be the exact reason we exist at all.